Everyone, welcome to my channel. So continuing with our series called fast revision, I would tell you what we have done in the previous video. So we discussed about the introduction, we discussed about position of hydrogen in the periodic table, then we discussed isotopes, we discussed important tables, preparation, occurrence, properties, then important questions, uses of dihydrogen, hydrides, and mark lines, important portions, previous years. So in this video we would be discussing about water, its properties, and hydrogen peroxide, its structure, etc. So let's just not waste much of time and start our interesting topic. So देखो, when we discuss about water, so यहाँ पे ये वाली चीज़ बहुत important आ जाती है कि human body has about 65% water and plants as much as 95% water. देखो, if you just discuss about the human body के अंदर, if you ask from anyone, someone would say that human body has 70% water. बट अब अगर हम हाइड्रोजन चैप्टर के पॉइंट ऑफ व्यू से देखें, सो दिस इज रॉन्ग बिकॉज ह्यूमन बॉडी है सिर्फ 65% water and plants are about 95% water. So this was important in this paragraph. Next we move down to this table. You don't have to learn the data that oceans में कितना percent water supply है, इस पे कितना percent है. You don't have to learn these values. Just coming down we have physical properties of water. So इसमें बहुत common information आपको देखने को मिलेगी that everyone knows that it is colorless, tasteless liquid, etc. यूजुअल प्रॉपर्टीज ऑफ वाटर इन द कंडेंस स्टेट, ये बहुत एक कॉमन इन्फॉर्मेशन है. लेट्स जस्ट कम डाउन, जो कि सबसे इंपॉर्टेंट इन्फॉर्मेशन है. देखो, सबसे पहले जब हम इन प्रॉपर्टीज की बात करते हैं, हायर स्पेसिफिक हीट, देन योर थर्मल कंडक्टिविटी, देन योर सरफेस टेंशन एंड योर डाइपोल मोमेंट, योर डाइलेक्ट्रिक कांस्टेंट. इसमें वाटर की सबसे हायर वैल्यूज होती है. ये बात आपको याद रखनी बहुत इंपॉर्टेंट है, एंड दिस इज एन इम्पॉर्टेंट पॉइंट. ओके, सो लेट्स जस्ट मूव डाउनवर्ड. फिर हमें एक टेबल देखने को मिलती है. सो इसमें बस लाइक ये तुम्हें पता ही है that D2O is known as your heavy water, but you don't have to learn these values. As such एग्जाम्स में पूछी नहीं जाती है. बुक्स में इसके क्वेश्चंस I didn't found any. सो लेट्स जस्ट मूव फॉरवर्ड. तो ये टेबल इतनी ज़्यादा इंपॉर्टेंट नहीं होती है. देखो, यहाँ पे एक लाइन आती है दैट इज़ वेरी इंपॉर्टेंट. देखो, अब जब हम ये वाली लाइन पढ़ते हैं, सपोज ये क्वेश्चन ऐसे आता है कि लिस्ट 2 फैक्टर्स दैट आर रिस्पॉन्सिबल फॉर moderation of climate and body temperature of living beings. Sorry. So the question comes out to be like this, that list 2 factors that is responsible for moderation of climate and your body temperature. So अगर हम ये क्वेश्चन इन एग्जाम देखते हैं, सो किसी को भी कोई ऐसा क्वेश्चन लगेगा कि ये इकोलॉजी से क्वेश्चन है, बट लिटरली एक हाइड्रोजन चैप्टर के अंदर ये गिवन है कि द 2 प्रॉपर्टीज आर हाई हीट ऑफ वेपराइजेशन एंड heat capacity. These 2 are the things that are responsible for moderation of climate and body temperature of living beings. So ये वाले जो पॉइंट है अगेन इंपॉर्टेंट पॉइंट है एंड स्टूडेंट्स इग्नोर कर देते हैं. अब हम आते हैं स्ट्रक्चर ऑफ वाटर पे. देखो, स्ट्रक्चर ऑफ वाटर हमें क्लास 11 की ही केमिकल बॉन्डिंग चैप्टर में वी जस्ट रीड अबाउट. वी हैव वेस्प थ्योरी, वी हैव मॉलिक्यूलर थ्योरी, बट हियर सिंस वी आर डिस्कसिंग अबाउट वाटर, सो इट्स इंपॉर्टेंट टू डिस्कस इट्स स्ट्रक्चर. सबसे पहले इसकी शेप आती है. वाटर की शेप कैसी है? वी से दैट इट्स अ बेंट मॉलिक्यूल. इसका बॉन्ड एंगल याद रखना बहुत ज़रूरी है. इसका बॉन्ड एंगल है 104.5 डिग्री. अब देखो, इसकी जो बॉन्ड लेंथ है, वैसे ये नीट के पेपर में आनी, मतलब ये अभी तक नहीं आई है, बट स्टिल यू कांट टेक अ रिस्क, यू हैव टू मेमोराइज दैट द बॉन्ड लेंथ इज 95.7 पिकोमीटर. बट या जे के एग्जाम्स में ये आ सकती है, नीट के एग्जाम्स में कम चांसेस है, बट या यू मस्ट रिमेंबर दैट द बॉन्ड लेंथ इज 95.7 picometer and the shape is here. Again, here also it's written that the shape is bent molecule, bent structure. Okay, let's just move forward. Okay, देखो, ये वाला लाइन बहुत इंपॉर्टेंट है कि वाटर क्रिस्टलाइन फॉर्म से पहले आइस है. ये तो बहुत एक कॉमन इन्फॉर्मेशन है, लेकिन आइस 2 तरीके से क्रिस्टलाइज होती है. अगर क्वेश्चन में आपका ये दिया हुआ है कि एटमॉस्फेरिक प्रेशर पे आइस किस फॉर्म में क्रिस्टलाइज होती है, सो द आंसर वुड बी योर हेक्सागोनल फॉर्म. इफ द क्वेश्चन ऐसे पूछा जाता है कि एट लो टेम्परेचर व्हाट इज द शेप, So you have to answer that the low temperature, the shape is your cubic form. So the two way the questions can be asked. One, it can be at atmospheric pressure, ice crystallizes in hexagonal form. At low temperature, it crystallizes in cubic form. Okay. Structure of ice may, if you see, not much important to be remembered out, but yeah, you can remember that the atoms कितने distance पे होते हैं. They are at a distance of 276 picometer. But ये वाला question ऐसा बुक्स में नहीं देखा है और ना ही सीरीज टेस्टीज वगैरह में देखा, but still you can remember. ऐसी कोई चीज़ नहीं होनी चाहिए जो हमें याद नहीं होनी चाहिए. So we can remember that the atoms are at a distance of 276 picometer. Okay, coming down to chemical properties of water. यहाँ पे देखो, important information is your amphoteric nature. सबसे पहले we know that the water is amphoteric. That means amphoteric का मतलब यही होता है कि it can act as acid, it can act as base as well. तो हमें ये पता है autoprotolysis और self ionization reaction से हमें ये पता चलता है कि water also can act as acid and water can also act as your base. यहाँ पे आप oxidation number से बिल्कुल पता कर सकते हैं कि इसका oxidation जो है वो बढ़ भी रहा है और इसका oxidation is also getting reduced. So it's showing that water is an amphoteric nature. बस और कुछ इसमें ज़्यादा जानने की इतनी नीड नहीं होती है. Redox reaction involving water. So these are very very simple reactions that you can all just read out. So I have ticked out कि yeah, it's a casual information जो हम सारे obviously पढ़ सकते हैं and इतनी ज़्यादा बड़ी questions में नहीं पूछी गई है, but this is a very very casual information. जब सोडियम को हम वाटर में मिक्स करते हैं, so we get your sodium hydroxide pops out the hydrogen gas. So this information is very simple. F2 plus your H2O, we get, combine it, we get HF, right? So this is very common information, so I'm not discussing about it. Let's just move forward. We get, देखो this line is very important. देखो मैं आपको बताती हूँ कि जब आप ओपी टंडन बुक सॉल्व करेंगे या फिर आप एररलेस बुक सॉल्व करेंगे, जीआरबी की और भी डिफरेंट बुक्स आती हैं वो सॉल्व करेंगे, वहाँ पे सब टेस्ट सीरीज में आपको एक क्वेश्चन जरूर मिलेगा कि ड्यू टू योर high dielectric constant, it has a strong hydrating tendency. How is the question being asked? The question is asked in this way, that what is the reason that it has a very strong hydrating tendency. So you have to write or you have to tick out that answer that says out that the high dielectric constant. So what is the key word here? Dielectric constant. Okay, again important lines. Many way, you know, many places you will find this line as your question. अब like this line again, this ये जो information है, coordinated water, interstitial water, hydrogen bonded water, many students would ignore this line thinking that it's not important, but no, you will find these questions in many test series and also in your errorless book. How, what you have to do in this, you don't have to read these lines, आपको सिर्फ coordinated water का formula पता होना चाहिए, आपको interstitial water का formula पता होना चाहिए, and hydrogen bonded water. You have to learn all these formula of these three water: coordinated water, interstitial water, and hydrogen bonding water. That's it. So this is a question that comes in your paper. This is a question that comes in your paper, in your test series also. Then in many books you will find this as your question. Okay, so let's just move forward. Then we get a in text question that how many hydrogen bonded water are associated in this. So हमें देखते हैं कि CuSO4.5H2, but out of them you will find that only one water molecule, सिर्फ एक water molecule is there that is outside the bracket, that is coordination sphere. You know what is coordination sphere? So this is basically you learn in the chapter, in your class 12 chapter, that is your coordination compounds. There is a coordination sphere, and the molecule that is there inside the square brackets, उन्हें उसे हम coordination sphere बोलते हैं basically. So इसमें सिर्फ एक ही आप देखोगे water molecule is there that is outside the bracket, यानी कि उस sphere से, like सपोज हमारे पास ये कोऑर्डिनेशन स्फीयर है, यानी कि ये एक स्क्वायर ब्रैकेट है, इसमें जो भी फॉर्मूला होगा, सो यू विल साइड डॉट, यानी कि सिर्फ एक वाटर मॉलिक्यूल जो होता है दैट इज आउटसाइड योर दिस स्फीयर, अदरवाइज you will say that four molecules of your water are coordinated. So again, this problem or this in text question is very very important. Okay, so ये आपको क्वेश्चन मिल जाएगा ओपी टंडन में, यहाँ से क्वेश्चन पूछा गया है. लेट्स जस्ट मूव फॉरवर्ड. वी गेट हार्ड वाटर एंड सॉफ्ट वाटर. सो हियर वी हैव कि सबसे पहले जो इम्प्योरिटीज होती है वो कैल्शियम और मैग्नीशियम सॉल्ट्स की वजह से होती है. एंड व्हाट आर द बेसिकली द सॉल्ट्स? दे आर आइदर हाइड्रोजन कार्बोनेट, क्लोराइड्स और योर सल्फेट. सो वी से दैट द वाटर इज हार्ड. So other marked portions are not much important. So let's just move forward. Okay. So we get out here temporary hardness. Now हम देखते हैं कि temporary hardness from this topic the question has come in NEET 2019. So we have to read this temporary hardness very carefully. सबसे पहले हम ये देखते हैं कि temporary hardness होती किस वजह से? It is due to हाइड्रोजन कार्बोनेट्स. मैग्नीशियम और calcium तो है ही, but what is the salt? It is hydrogen carbonate. So we have two methods to remove your temporary hardness. One is your boiling and the other is your Clark's method. Let's see कि ये दोनों methods में क्या है. बॉइलिंग में यू सिंपली बॉयल इट, बट यहाँ पे इंपॉर्टेंट क्या हो जाता है जानना कि मैग्नीशियम हाइड्रोजन कार्बोनेट इज गेटिंग कन्वर्टेड टू योर MgOH होल ट्वाइस एंड कैल्शियम हाइड्रोजन कार्बोनेट इज गेटिंग कन्वर्टेड टू योर कैल्शियम कार्बोनेट. सो दीज रिएक्शंस आर वेरी इंपॉर्टेंट. यहाँ से क्वेश्चन आपका पूछा गया नीट 2019 में. Right. The next method is your Clark's method. Simply, Clark's method में we add lime and we have these following reactions which are very important for you to know. So temporary hardness, we saw there were two methods. We revised those two methods and is like magnesium के में reaction में it is getting converted to hydroxide, and in case of calcium it is getting converted to calcium carbonate. Then Clark's method may we see when we reacted with the lime, calcium being converted to calcium carbonate, and when we are reacting magnesium, so calcium carbonate is being formed, but along with that magnesium hydroxide is also getting formed. So done. Next we move to permanent hardness. Permanent hardness is due to the presence of chlorides and sulfates. Like ऊपर हमने देखा था temporary hardness is due to hydrogen carbonates. देखो सब में आपको hydrogen carbonates मिलेगा, and here you will find chlorides, then your sulfates, etc. अब permanent hardness also remove करने के लिए हमारे पास like few methods है. Let's just revise those. सबसे पहले हम करते हैं treatment with your washing soda, यानी कि we just treat it with your washing soda. We get the following carbonates, and we get sodium salt of whatever salt it was. Like in the case of chlorine we get sodium chloride, and in the case of your sulfate we get sodium sulfate, right? So next method is your Calgon method. अब Calgon method से question कैसे पूछा जाता है कि what is Calgon? Calgon is your sodium hexametaphosphate. Calgon is a sodium hexametaphosphate. It is important to know its formula. Okay. So let's just move forward. Here reactions, वैसे not much questions have been asked from this reaction, but you must be thoroughly reading these reactions. Okay. The next is your ion exchange method. Ion exchange method is also called your zeolite permutate method. और इसमें zeolite permutate, what is zeolite permutate? Question ऐसे पूछा जाता है कि what is zeolite permutate? So the answer is your hydrated sodium aluminium silicate, right? So when it is said to be exhausted, ऐसे भी क्वेश्चन पूछा जाता है, permuted zeolite is said to be exhausted when all the sodium is being used up. So बाकी इतनी information as such कोई important नहीं है, reactions इतने पूछे नहीं जाते हैं इस chapter से. So let's just move forward to the synthetic resin method. Synthetic resin method, what is important? यहाँ से कैसे क्वेश्चन पूछा जाता है कि which one of the following is the most efficient method? So you have to write synthetic resin method is the most efficient than your zeolite process, right? अब देखो इसमें एक्सचेंज कैसे होता है, ये इंपॉर्टेंट बड़ा है जानना. लाइक इसमें RSO3H, दैट मीन्स सोडियम, योर सल्फोनिक एसिड इज बीइंग कन्वर्टेड टू RNA, sodium salt, right? And how it is being converted to sodium salt when we just treat it with your sodium chloride, right? यहाँ पे R क्या है? यहाँ पे R है resin anion. And next is important that how the resin it can be regenerated. Regenerate कैसे कर सकते हैं हम उसे? By treating, by adding it with sodium chloride solution. Okay, so ये आपका synthetic resin method था. नेक्स्ट अब देखो इस प्रोसेस में आपको ये जानना इम्पोर्टेंट है कि cation exchange process H plus exchanges with Na plus Ca2 plus and Mg2 plus, right? Moving forward, we get OH minus exchanges for anions like Cl minus, H2O3 minus and SO4 2 minus. Okay, so here we say like what is more important from your temporary hardness and also from your permanent hardness? So you will say that temporary hardness is more important because the question NEET 2019 question has come from your temporary hardness. Otherwise permanent hardness के methods and important lines कैसे याद करनी है, I have already told you all these things. Let's just move forward to your hydrogen peroxide. So hydrogen peroxide में you have the following reactions. देखो, acidified barium peroxide में you just acidified barium peroxide and removing the excess water by your evaporation. यहाँ से इतनी बार question इतना नहीं पूछा गया, but yes you can just you know revise your reaction. Next is peroxodisulfate that is obtained by electrolytic oxidation of acidified sulfate solution. अब देखो यहाँ से question कैसे पूछा जाता है आपके different books and test series में. क्वेश्चन ऐसे पूछा जाता है कि दिस मेथड इज नाउ यूज्ड फॉर योर लेबोरेटरी प्रिपरेशन ऑफ योर D2O2 and industrially how it is prepared by your O2 proteolysis of two alkyl anthraquinols. So the question will be asking you in this way कि laboratory way में हम कैसे उसे prepare कर सकते हैं and industrially way में how it is being prepared. So these ये जो दो lines है यहाँ से आपको mostly books में जो है questions मिलेंगे. Okay, the question is being asked in this way कि how do you prepare from laboratory way, how do you prepare from industrial way. Otherwise from this line much questions have not been asked in your different books and series. Okay, so this reaction is also not much important. We will move forward in the physical properties. अब physical properties में आपको सिर्फ दो important lines है that is important to know. H2O2 का color कैसा होता है, that is very very pale blue. ओके अब देखो ये वाली लाइन अगर आप देखते हैं तो मोस्टली इसे स्टूडेंट्स जो होते हैं इग्नोर कर देते हैं, बट दिस लाइन इज आस्क्ड एज अ क्वेश्चन इन योर ओपी टंडन, देन योर एरएलएस, also your some other books. So how is the question asked? A 30% solution of H2O2 is marketed as 100 volume hydrogen peroxide. So this line is again important, you will get in your many test series and also in your different books. अब देखो जब हम हाइड्रोजन चैप्टर को देखते हैं, इनऑर्गेनिक को देखते हैं, सो वी अज्यूम दैट मोस्ट ऑफ द क्वेश्चंस फ्रॉम दिस चैप्टर वुड बी आस्क्ड इन एन एमसीक्यू वे एंड देयर वुड बी नो न्यूमेरिकल्स फ्रॉम दिस चैप्टर. बट हियर वी गो रॉन्ग बिकॉज न्यूमेरिकल्स भी इस चैप्टर से सिर्फ एक ही टाइप का न्यूमेरिकल बनता है और जिसका एक ही फॉर्मूला है. लेट्स जस्ट फोकस ऑन दैट न्यूमेरिकल सो दैट नथिंग गोज रॉन्ग फ्रॉम दिस चैप्टर. देखो ये वाला न्यूमेरिकल बहुत इंपॉर्टेंट है, प्रॉब्लम 9.7 9.5 सॉरी. सो इसमें ये सारे न्यूमेरिकल्स वट एवर बी द न्यूमेरिकल दैट हैव बीन आस्क्ड फ्रॉम दिस चैप्टर, उस वो सारे न्यूमेरिकल सिर्फ एक ही फॉर्मूला बेस्ड होते हैं, दैट इज वॉल्यूम स्ट्रेंथ इज इक्वल टू 11.2 m एंड व्हाट इज m हियर? m इज मोलारिटी. m is molarity. So ये वाला फॉर्मूला सारे क्वेश्चंस में हम लगा सकते हैं and we can get the answer. So only one numerical is being asked, मतलब one type of numerical is being asked from this chapter. So we have discussed the numerical as well. Coming down to the physical properties, ये वाली table इतनी ज़्यादा important नहीं है. So let's just move downward. We here see the structure. In structure देखो, we know that H2O2 structure that it is non-planar. बट देन दिस इज़ वेरी इंपॉर्टेंट कि गैस फेज में उसका डाईहेड्रल एंगल होता है 111.5 डिग्री एंड इन सॉलिड फेज इट्स डाईहेड्रल एंगल इज 90.2 डिग्री. राइट, ये वाली जो इन्फॉर्मेशन होती है मोस्टली स्टूडेंट्स इग्नोर कर देते हैं, बट दिस इज नॉट द इन्फॉर्मेशन टू बी इग्नोर्ड. सो टू थिंग्स वॉज इम्पॉर्टेंट फ्रॉम द स्ट्रक्चर. Let's just move downward. We get the chemical properties. From here, much questions have not been asked in your exams, but let's just focus and know that how to read the reactions and all. Okay. So, see, what you need to know, like Fe2 plus and your Fe3 plus. What is happening in this? In this, you see that there is a increase in your oxidation number. So, what is happening? Oxidation. So, we see here oxidizing action. Then here MnO4 2 minus में what is oxidation state of Mn? It is +7 and it is being converted to Mn2 plus. So there is a decrease in the oxidation number. So we see here reducing action. Again Fe2 plus being getting converted to Fe3 plus. We see here oxidizing action. Here again देखो I2 में oxidation number is 0 and it is being converted to your I minus. So here we see a reduction. So these reactions आपको ऐसे पढ़नी है कि H2O2 can act in the form of your oxidation as well as your reduction. Okay, so we have learned about these reactions as well. Let's just move forward. In the storage, we say that they could. This is very easy and common to know that H2O2 slowly decomposes on exposure to light, and this is the reaction that is given out. Very easy and casual information. Okay, so this is very important. देखो यहाँ से where to be stored. So the answer is wax line glass or plastic vessels in the dark. Then what is added as a stabilizer? You add urea as a stabilizer. Then what dust can do to it? Dust can induce explosive decomposition of the compound. So what do we see here? We see here three questions. कहाँ पे स्टोर करते हैं, कौन सा स्टेबलाइजर ऐड करते हैं, एंड व्हाट डस्ट कैन डू टू इट. सो यहाँ से थ्री क्वेश्चंस कैन बी framed out. Uses of uses of H2O2, I haven't seen much questions, but yeah, we can't ignore if it is given in the NCRT. But इसे करना कैसे? Let's just see out that. Sorry. Let's just see how to do it in daily life. But how do we use it as? We use it as hair bleach and your mild disinfectant. Then how do we use in the form of antiseptic? Antiseptic may we use in the form of perhydrol. Then we use high quality detergents, right? So how is high quality detergents being made? It is made from sodium percarbonate and percarbonate, and H2O2 is used to manufacture your these two chemicals, right? Then pharmaceuticals may how you are using it. Pharmaceuticals may you are using in the form of your cephalosporin. So in uses you can just know this for information that how it is used in your daily life, how it is used in your high quality detergents, then your pharmaceuticals, etc. Right. Then we come to your heavy water. Heavy water may see there are two questions that have come from this heavy water. One is your AIPMT 2010 and one is your AIMS 2017. So we need to read this line or this paragraph very important and very carefully we need to read this line. Let's see what it is. How is ZD2O, that is known as heavy water, how is this used? Number one, moderator in the nuclear reactors. Number two, exchange reactions for the study of reaction mechanism. So these two are the uses of your heavy water, and it has come in 2 years, 2010, 2017. These reactions again are very important. You must revise these reactions. Important and mostly ignored by the students. Okay, so let's just move downward. डाईहाइड्रोजन एज अ फ्यूल. अब जब हम पूरा पढ़ लेते हैं सो मोस्टली डाईहाइड्रोजन एज अ फ्यूल वाले टॉपिक को हम इग्नोर कर देते हैं, बट वी नेवर नो दैट द क्वेश्चन कुड बी आस्क्ड फ्रॉम दिस टॉपिक एज वेल. देखो अब देखते हैं यहाँ से आईआईटी का क्वेश्चन पूछा गया है. How the question was being asked, let's see. It was asked in this way that there are two cylinders and one has a dihydrogen and the other has your petrol. So which one of them would be heavier and by how many times? So let's see. If you talk about a cylinder of your dihydrogen weighs about 30 times. What is the key word? 30 times. 30 times as much than a tank of petrol containing about same type of energy. And so देखो, this was asked in your JEE examinations. So the thing is that you need not ignore this line. This is important. And it is converted to liquid state by cooling it to your 20K Kelvin temperature. Now, this line is again important that dihydrogen can release more energy than your petrol. Question could be asked in this way that which one of the following will release more energy? Answer is dihydrogen, then petrol. And how many times? About 3 times. Pollutants and combustion of dihydrogen will be less than your petrol. Again, these two lines was important from this whole chunky portion. Okay. Then we have your hydrogen economy. Of hydrogen economy, so how the question could be asked, let's just see this. The question is asked in this way that what is your basic principle of your hydrogen economy? So basic principle of hydrogen economy is transportation and storage of energy in the form of your liquid or gaseous dihydrogen. Okay, next line, this is important. Initially 5% dihydrogen has been mixed in CNG for use in your four-wheeler vehicle. Self-explanatory line है, so need explanation. We come to this table, which is not as much important, not been asked in your much papers and series. So we have learned hydrogen chapter, we have learned very thoroughly. We have revised the lines, most important lines that have come in your previous papers or that are present in your different books. Now what should be your step after watching the video? Number one step should be that you must be reading the NCRT very thoroughly. Number two point should be that these marked portion should be there on tips in your mind. It should be very very, clear in your mind. The third step should be that you should solve different books for your inorganic chemistry. What I would recommend you for different books would be, number one, you can solve OP Tandon book, very amazing book, you can go for that. You can go for errorless. Then you can go for your GRB के different books आती हैं. You can go for your coaching material. Coaching का module में भी you will find different questions. Then you can solve previous years. All the previous years we have discussed many in our PDF. So after you do these four books that I have recommended you, and you revise the NCRT and mark portions, I assure you this chapter will really be on your tips and you won't miss a single question from this chapter. So I hope and expect that you would all fulfill all these steps, so that this chapter becomes very easy for you all people. So by the time you keep enjoying, keep learning, keep studying. Hope you all like the video. So please share, like, and subscribe to my channel. So thank you.